All right, today we're going to talk about signal path. Simply put, signal path is the route that a signal takes to get from point A to point B. Here's an illustration of a typical signal flow chart. All right, so one of the first parts of your signal path is going to be your preamp. So usually have your input and then your preamp, okay? So input, preamp, channel strip, fader, effects bus, output. So preamp is one of the first things in signal path, sometimes labeled as mic gain, trim, or input preamp. It is basically the amount of gain you add so that you bring up that level of your microphone. So here's another definition. This is a start. Whatever hits the input stage, a preamp is a necessity for any mic to bring its output to line level. Your preamp's gain or trim can be adjusted. Gain refers to how much a signal is amplified as it passes through a circuit or device. Trim refers to changing the level of a signal up or down to more appropriately align it for a particular device. Okay, so gain is your knob, trim is usually going to be the fader. If we look at a channel strip, here is a virtual channel strip in Pro Tools. Here is an analog channel strip. Let's look at this one. So in Pro Tools, your signal path is your input and output up at the top. Your automation, we'll get into automation later, but automation usually up here. Your group, your panning dial, your panning display, record and enable, solo, mute, your fader, velocity meter, and then you have your volume, which is a representation of this fader, your track name, and then the track type right here. And a typical analog channel strip, you have your input. You have, so this is the whole input section. So you would have like an insert here that goes between your input. You have your gain control. This one has a compression, and then it also has a high pass filter, meaning it wouldn't, you can cut off basically all of your pre-80, this one's set at 80, anything below 80 would be filtered out. You have your compression, just one knob compression, 3-band EQ, your auxiliary send, your effect send, and then your pan control. You have a mute. This stands for pre-fader listen. So if you click that, it basically bypasses a fader. Sorry, I'm trying to. And then you got your fader, flash volume control. Okay, let's talk about adjusting channel gain. So to do this, you want to set your fader to unity and turn the preamp down or up so that the master fader, typically the book tells you to start your master fader at about -30 or lower to recognize the signal. This definitely is good for if you're doing live sound, starting out so that you don't blow anything up as far as speakers, or you don't pop a speaker or something. But once you get more experience with it, you kind of have more knowledge of where to start that at. But when you're setting your gain, watch the meters for heavy transients that could clip or distort as the source is being checked. Slowly increase the gain, watching the meters. For recording levels, you want to make sure of a couple things. Levels are going to vary depending on the source. So line level instruments such as keyboards could be right at -12 to -6 dB, while mic'd instruments or vocalists might need to be a little bit higher to get them to cut through the mix, -6 and up. The idea is to get a nice warm signal without distortion, okay? So your line level signals, usually you don't need as much gain for them as what it's saying, and then your mic signals, you probably need a little bit more gain. Unity gain refers to the state where the circuit output are the same level as it receives in the input. So you're not you're not attenuating that gain down, and you're not amplifying it up any. Let's talk about headroom. So this is the operational range between normal and maximum signal level. Okay, that's what your headroom is. So it is basically basically like a normal range up until the highest amount of gain possible where it doesn't distort. That's what your clean headroom is. An attenuator or pad is used to cut a strong signal going into the preamp to avoid unacceptable distortion. So if you have a very hot mic, say like a small diaphragm condenser, a lot of them will have a pad on it or an attenuator that will bring the level down, say negative 20 dB. So whatever's going and hitting that preamp is going to be attenuated 20 dB down than it would have normally. And this, if you have a very hot signal, this could help to not have distortion going into your preamp. Signal to noise ratio is a measure used in science and engineering that compares the level of a desired signal to the level of background noise. So signal to noise ratio is defined as a ratio of signal of power to the noise power. Okay, signal power to noise power, often expressed in decibels. A ratio higher than 1:1 indicates more signal than noise. Okay, here's a representation of that signal to noise ratio. Received signal strength, and here's your noise down here. So that's fine. Let's talk about phase. Phase is whenever two or more microphones pick up the same waveform. There's a likelihood that the mics will hear the waveform at different points in the energy cycle. Okay, and we've talked about this before. These two equal in phase. Okay, these two equal exactly out of phase, 180 degrees. Okay, these are partially out of phase. Let's talk about channel inserts. Okay, channel insert is the point where a piece of outboard signal processing can be plugged into a signal path on each individual signal or each individual channel. Okay, if we look at a channel insert in an analog board like this right here, you will see you got one insert cable. Okay, it's a TRS cable that goes into the insert and then becomes a Y cable with a TS and a TS, a left and a right. Okay, it's really the input and output of whatever effect you're using. So this is saying this is an effect right here. You go in and out of the effect, and it goes into the channel insert, and then you can choose how much of that insert you want in your signal path. Okay, here's just a text representation of that. So microphone goes into preamp, then gets taken to the TRS insert, goes to the effect, comes back down the fader, and then goes the rest of the signal chain. Okay, let's talk about effects buses or auxes. Same thing. Bus equals an aux. So they're the same thing. So this lets you send a mix from the bus to an effect, leaving the master mix on the input faders without effects. Okay, so if you instead of putting them onto a channel, it goes to a bus, and you can bring that bus up separately. So signal flow for this insert effect, track signal. Then it goes to the insert effect. Then it goes to a stereo bus or audio interface output. Okay. For a send effect, what it does is it takes your signal and it goes to the effects bus. Then it comes back up to the signal before it hits the stereo output or audio interface output. So it's in the actual signal, and this one up here is separate. All right, let's talk about input faders. These are used to set the recording levels during tracking in a recording session. A live session would use these to mix individual levels. Also, if you're mixing on a mixing desk and you have your tape playback going through it and you're printing your mix to Pro Tools or tape or whatever, your input faders are going to actually be your mix as well. So we've already talked about the signal flow, but with your input faders, you are basically going to be mixing the sound of each individual track. So each individual instrument or mics used on those instruments or whatever it is, virtual instrument, they'll all be adjusted with the volume fader. And they can also be automated to go up to different values at different times in the song. So a lot of times when I'm mixing a song, I'll automate several of the instruments to be at different levels during different points of the song. Let's talk about pre and post. The pre and post button basically chooses whether each individual point in the bus hears the signal before it goes to the EQ and fader or after the EQ and fader. So, basically to send your signal to the bus, do you want it to go through the fader or not? There's certain times where we would want this, certain times we wouldn't want this, but we'll get into that later on. Let's talk about panning. This allows the signal to be adjusted left or right. So if you have a stereo mix, meaning two speakers, your pan is going to say how much of each of those tracks. If you have all these mono tracks, this one you're only going to hear it on the left speaker if it's panned 100% to the left. This one, the right, if it's panned 100% to the right. This one, you're going to hear it equally in both, okay, because it's in the middle. Okay, gain structure. Gain structure refers to the relative levels of signal as it moves from the source to the destination. At each point where level changes are possible, you must monitor the signal strength and, if possible, solo the signal. Okay, you need to establish and maintain good gain structure, signal strength throughout the entire sound system, and also throughout your entire mix. One of the things I know I struggle with in mixing is, especially if I'm mixing in a DAW, is gain structure throughout it, because I'll put several compressors, mini signal processors on it, and you have to leave yourself enough headroom originally to where by the time you get done processing the signal on a track, it does not distort going into the master bus. All right, so bouncing tracks or ping-ponging allows one to free up tracks by combining tracks to free up additional tracks. This is a tape. This is basically a tape technique. So if you had a four input tape machine, okay, to do this, you would basically you'd have this drums, violin, harpsichord, string bass on one track. You would then bounce that to bounce one, so you're playing back bounce one. You're gonna add three more tracks. So you have basic track, piano, vocal. Okay, then you can bounce that to bounce two, and then everything here is now on just one track. Then you have three more to play with. They did this in Sgt. Pepper's Lonely Hearts Club Band, that album. So track one, they had electric guitars and drums on the left-hand side. Track one, electric guitars, drums, and bass on the right-hand side. Track two, they had bass, audience, sound effects. Track three, backing vocals, French horns, lead guitar. Track four, lead guitar, backing vocals, lead vocal, backing vocals. Solo, or after fader listen, plays back only a selected track. PFL, pre-fader listen, solos the channel immediately before the fader. Mute turns off the channel. Talk about equalizers. An EQ, equalizer, allows for frequency adjustments. Okay, so if we look at this representation, this is what's called a parametric EQ or graphic EQ. No, this is a parametric EQ. So graphic EQ would be the one with the faders, the sliders. So these both are parametric EQs, but you can see this is how much. This is called your Q, how much you're affecting, how much space, and then it's the volume or level of that change. So you can see this one has about 15 dB at about 800 hertz with a fairly narrow Q. So that'd be a narrow gain bump of an EQ at around 800 hertz, about 15 dBs, which is a lot, honestly. And then you'll see parametric EQs that are like this. How you would work these is the high field is a set band. It's a set frequency, so you just raise or lower it. But then with your mids and your high mid and low mid, you can select what frequency you want and then affect it up or down. Same with low mid. Select what frequency you want, and you can go up and down. And then in your low field, it's a fixed band as well. All right, we just talked about bandwidth or Q, so I won't spend a lot of time on it, but bandwidth is simply the width quantified in octaves of a frequency spectrum. A human being hears a bandwidth of about 10 octaves. So when we're affecting a Q, this is just a representation of like a wide bandwidth would be black, the pink would be medium bandwidth, and the narrow bandwidth would be that blue right there. It's just a visual representation of it. All right, let's talk about types of EQs. We talked about a couple already, but sweepable EQ has a boost/cut control to determine the severity of the EQ, and the frequency selector lets you slide the bandwidth through a specific range. So technically, the one that we saw over here is a sweepable EQ, technically, and these kind of you can as well, but they're also parametric EQs. It's most flexible and powerful tone control. It operates just like a sweepable EQ, but gives you one other control, the bandwidth Q. So technically, this one's sweepable, and then this one is the parametric. But I've seen ones called parametric that don't have the bandwidth control. But as for like on the test and everything, just go by these definitions. And then you have your graphic EQ. This one has individual sliders that give you a graphic of all frequencies, what is boosted or cut. So this is a graphic EQ here. So you can see you can boost at 16K, cut at 8K, whatever. Let's talk about types of filters. There are several filters. There are several filter types of band adjusting filters, where an entire range of frequencies can be eliminated or adjusted uniformly. So this would be like a low pass filter. So you'd see your low frequencies are fine, and then it cuts out the highs. Lets the lows pass. Your high pass filter does the opposite. Lets the highest pass, cuts out all your lows. This one is a band pass, so it gets a specific band, and then this is a notch filter, which takes out certain amount. Patch bays, we're not going to get super into this, but basically patch bays are how you route your studio gear from one to another. I take a look at a basic session setup. You can pause this and take notes of this. And that's it. That's all for today.